Hello, everyone, and welcome again to the AI and Startups Innovation Program, How to Launch an AI Business, Product, and Services. So this is an Imperial College Business School, and it's like an executive education program. It's dedicated for people who are working and for CEOs, government officials, and the people who have an intention to start their own startup based on new technologies, mainly AI for us. So the program is more business oriented, and I know some of you were struggling with the technical aspect. So I thought to myself, why not doing a live coding session? So this is an opportunity for you to learn some coding skills. It's simple, and it will surely help you with prototyping your future ideas, and it's a good asset for you for the capstone project. I know I have given you the date of 24th of November, but there was no much momentum about that date. And I know most of you are working, the same thing for me. I'm working a full-time job, and this is like a second gig for me. So I thought maybe the weekend will be convenient for you. So here we are. I think I have shared screen with you. Yeah. So in here, we are on Reef, and in Times Square section, we're gonna just write, and we are live. So if you join me tonight, live streaming. So if you join me tonight, you can ask whatever you want, but if you cannot, it's no problem. I'm recording this session, so you should know if you ask a question or like you unmute yourself and speak to me directly, is going to be recorded, and this video will be shared with everyone in the groups. So we're going to start. By the way, for the people who are watching the recorded session, if you have any questions, please DM me or leave a message on the town square, and I will try to reach out to you as soon as I can. So in the search bar, just type Google Collab. So this is like an online collaboration platform for people who are developing their Python programs. It's usually AI programs, and it's free to use and simple to use. And if you do this same exact things on your laptops, it's going to be quite challenging. But in here, things are so simple. So this is me talking. I'm going to put myself in here so you can see me. And here we go. So for you, the resources, so most of the groups, they were like discussing NLP ideas. So I thought maybe this live streaming would be about NLP, but like skill set that you can gain, you can like deploy it like in time series based use cases or other similar use cases. Just shoot me a message and I will try to guide you through it. I'm gonna post this in here. This is the link for the labs we are doing. I know when I'm coding live, I made a lot of mistakes. This is the links for the labs we are doing. These are, since we're gonna use like several labs, so I think these are the links for the labs we're doing. So if you want to explore the source code that we have done, just go to that link. It's GitHub. GitHub is a platform for coders and where you can share your work. So that's my personal work. I usually give it to my students in engineering schools and some professionals who are learning. So I guess that's your case. Please feel free to use that link. And for Google Colab, you have the link in here. And of course, like this is the Zoom for people who like to participate live. So we are here, and the first use case we're gonna tackle is like an NLP classification. We're gonna try to build an NLP classification model. So we're gonna start by a library is very famous in machine learning. It's called scikit-learn. So it have most of the classical machine learning algorithms, and it's very simple to use. So in here, just go, after you click on the link, just go to scikit-learn and open this file. So I tried to put all the source code into one place, but hopefully with you tonight, we're gonna like make it clean. I did not have the time to have a clean code. So maybe like this like coding session is gonna be 2 hours. I put on Zoom it's 1 hour, but like I think it's gonna be 2 hours, since I will try like once and for all put the last version in here. And you will see errors. I will try to debug the source code with you, so you know what you're gonna face in the future. Even if you are a professional, debugging is always part of the work, if not most of it. So we're gonna import the libraries we are using, and we will try to have an organized source code. So in here, I'm gonna put text, and since I'm importing libraries, I'm gonna write libs, and we're gonna talk about these. So RE is a regex. Regex when you have like, for example, a word, but regex refers to regular expression. So the regular expression we have in our daily lives, we can extract some specific parts of it. So we use this library to extract specific things inside words, phrases, texts, and you can like extract a specific character, two characters. It depends on the expression that you put. After that, we have string. So we refer to text and a lot of characters as a string. So if you type down a text, this library will help you to manipulate your text easily. And then we have the famous pandas. Pandas is a great tool for data manipulation, and it's famous for having a data frame. If you are not from a coding background, you will think like, what complex thing will go to a data frame? But if you are coding in C, which I recommend if you wanna like have a very high computational speed for your program, you need to do that, and it's so complex. So in Python, things are simple, and pandas make tables manipulation really, really easy. Now for NumPy, it's a numerical Python library. I know for you, it's like, this is too technical, but if you have an AI startup, you gotta know this. These like the basics. You don't wanna hire an engineer or I don't know, a technician, and you do not know the basics. It's gonna be hard for you. Now, when we develop a model or a code, we need to accelerate it, to optimize it. So for me, I use the function tools, and I import the LRU cache. When the program is executing, I try to cache as much information as I can, so it speeds up my computing speed. And the difference can be big. So the program can run in the whole day, like 24 hours. You can cut down that running time into 15 minutes or 30 minutes. And that's like big, guys. So if you are starting an AI startup, efficiency is the key, and you need to optimize your code and accelerate your code. So that's how I usually accelerate my code. Of course, I try to optimize it. Now, the library we are using is scikit-learn, as I said, but scikit-learn, it has a lot of functions and libraries and classes to deal with NLP use cases, natural language processing use cases. But in here, I will try to incorporate another library that it focuses 100% on NLP, which is called Spacey. It's the second most used library for NLP challenges. And from there, we're going to import the English dictionary and the stop words. The stop words is like at, it, him, her. Those stop words, when we take them off of the sentence does not actually lose its sense. And they are so frequent in any text So you need to know, like, understand a little bit of linguistic, but like for computers, they do not really care about those kind of words, like from, where, to, he, she, they. You can like take them off from your text, and that will speed up your computing power, and your model will be most likely more accurate. This is how computers learn language. After that, we have the scikit-learn itself, that we will like the software and the go-to solution for beginners, and we will try to convert the English words into vectors. A vector in mathematics is a matrix where we're going to store a digital version, like a numerical version of the words. So let's say MK says hi, MK is going to be 1, says is going to be 2, hi is going to be 3. We will try to do that for every single word. And by the way, you can do that for characters too, but like it's not that efficient. And after that, like some words will have a certain frequency, so we need to analyze the whole text. And after doing that, so I think like this, you can see me better. So we will try to calculate the frequency of those words to determine which one is more crucial to the text we are using. So I know I said this is like a simple use case, but I think it's an intermediate level. But when you have a startup, it's never going to be a simple use case. So you gotta used to it. After that, we're gonna try to, in AI, we have two big things, like the data set itself that we're gonna import, and the data set is gonna be Amazon Alexa reviews. By the way, I'm gonna type that in the chat so I don't forget. So the use case of tonight is classifying Amazon Alexa reviews into positive reviews and negative reviews. If you see a typo, what that happens? The use case of tonight is classifying Amazon Alexa reviews into positive reviews and negative reviews. And this is the link for the data source. And it's going to be Kaggle. It's like the biggest platform for AI and data science competitions. Now I'm going to search for the link, and it's stored in my cache on my browser, and here we go. So this is the famous Kaggle, and this is where I gained most of my expertise, and the competitions can be $100,000 to $1 million. So I'm addicted to this platform, but unfortunately I work like very long hours a week, like 60 hours, sometimes 70 and 80. So I no longer do that. Hopefully in the future. And here we go. You have the link. My apologies for me changing the dates every time because it's super inconvenient for me. And I know like Saturday night, most people are partying, but you're still gonna have time to party. It's like, if you're gonna party, it's like after 10 or 11. It depends on your country. But for me, like in my country, is after 10. Here we go again. So the algorithm that we're going to use is called logistic regression. It's linear. It's a linear equation to classify models. And here we go. So this is how logistic regression looks, and this is how linear regression looks. And it's like in here, it's fairly linear data, but like it's definitely better than linear regression. So this algorithm will determine if my reviews are positive or negative. So we will go back to the notebook. So this is called the notebook to execute any. So after the creation of the model using the trained data, we're gonna test it with the test data. And we're gonna evaluate how accurate our model is classifying Amazon Alexa reviews. So for that, we need metrics like accuracy, precision, F1 score, recall, and other metrics. We're going to discover them together. So sit tight, and here we go. If something does not work, we will try to make it work. So do not worry about anything. By the way, if you want to accelerate your compute, you can change the runtime to a GPU, and it's a graphical process unit. So in AI, it's usually we do matrices multiplications, and it's preferable to use a graphical process unit, which is like good for gaming. If it's good for gaming, it's good for AI. The camera is here, and I keep looking at myself at the bottom right. It's kind of like silly. And then you have the TPU, which is tensor processing unit, but that's another concept for another day. And it's super important that by the time you will start your own startup, you will definitely know about all of these aspects, even if you hate like technical aspects. And here we go. We're gonna import our, so this is my cheat sheet or my cheat code. And I will be copy pasting from that. So I prepared a lot of code before this session. This is why I have one of the reasons to change the dates every time, because I was not ready. So, and here we have the data. Here we go. But this is like a cloud platform. We need to upload that data. So what we're gonna do is we're gonna go here and upload. For me, I have downloaded it. And for you, you have the source code, the reminder. Oh yeah, this is like the source code. Gonna take it, put it in here. Source of the data. If you want to put the comment, you can just do, I don't know about your keyboard, so you need to figure out that by yourselves. Depends on the keyboard. For me, I use an AZERTY keyboard, which is like a French keyboard. And that's mainly because my second language is French, and my third is English, and my fourth is German. And I regret not learning Spanish. Spanish is a very beautiful language. I want to learn Italian too. So the data in here, I need to copy the path where my data exists in this virtual environment. And here we go. Hopefully it works. And we are good to go. So we're gonna only take 500 reviews, so the calculations are fast. Once we set up our code and it works, we will use the full data. But before doing that, we need to explore a little bit what we have in this data set. And it's like this. So in this data set, I have the ratings from 1 to 5. 5 is really good. 1 is bad. I think we have a 0 too. But you have an idea. This is like a classification use case, is supervised learning. And in supervised learning, this is the text that my model is going to learn. And this is the feedback. So if you have a feedback of a 0, this is a bad review. You have a feedback of 1, this is a good review. And we're only going to use the feedback and the verified reviews. I know this helps like the data rating and variation, but it's just like a simple use case like I promised. So do not hang up on that detail. Now for the data that we are going to use to train our model, it's the X. I call it X. And this is like the text that we have, and in here we have the labels. Are those texts positive or negative? And here we are. Most of them are positive, and this is the problem with this data sets. Like most reviews are positive, so it's like a little bit difficult. Actually, it's not difficult. It's like it's a kind of unbalanced data set where we have more positive reviews than negative reviews. Now we will go to configuration. This is, we're gonna put an indication in here and we say configuration. We're gonna take off the punctuation from the text. So we take off the stop words, we take off the punctuations, and we're gonna use a dictionary. It's called English Core Web Small. And for that, we need to download it, but let's just hit Shift Enter and see if it works. And it works. Why? It's because I imported the whole spacey thing. So it brings me all the data. But on your laptops, if you do that, you need to download it by yourself. Now, I'm going to define an optimized function. One day you will thank me for this. It took me a while to figure out. I'm not an NLP expert. So I spent several days working on these different use cases. And in here, we're gonna clean the data, the function that is gonna clean the data. It's called processing. Oh yeah, processing. So this is the library and the function that is gonna cache most of, like every time we call this function is gonna cache as much as possible from data to make the calculations faster. And this is called comprehension list. It's really big data friendly because it accelerates the way the functions are behaving. I will not deep dive into that, but like it's good to know that. So for here, I'm seeing another room for optimization. So a sentence in here has this treatment, and I have an empty sentence in here. And this function, it takes off the trailing and overflow white spaces. But I'm gonna put it in here. Let's see if it works. So instead of calling one variable twice and doing like separate processing steps on it, we will incorporate everything into one place. Now, one of the most important things is to use the lemmatization. So when you have the word work and working, they are the same. So if you have working and I use lemmatization with spacey, working is going to be like work. We're going to take the ing from the end of the word. Why? Because like worked, working, and work should be processed as the same word. And for that, we use the lemmatization. It's better than using stemming because stemming is very unprofessional to use it. So for me, I always go to lemmatization and I take off the punctuation, I take off the stop words, I take off the overflow white spaces and the trailing spaces. And like I said, the ing, the ed at the end of the past, like when you have different tenses of the verb, you will only keep the main word, like work. After that, what we're gonna do, this is the code. We need to be careful. Number of empty cells. We will only take the thing Okay, I'm gonna take this code, and this step is called training the model. Usually, so this is like a very short version of what we do. So if you think it's simple, it's just for this tutorial's sake. And in here, modeling. So what we're gonna do, like we're gonna transform the text into numerical data, and then we're gonna do feature engineering with TF-IDF, which is a way to figure out which words are important in the whole text, and then we're gonna train them. We're gonna train them using, I will change this to logistic regression. And I'm gonna hit Shift Enter. Pipeline is not defined, so we need to go here and define the pipeline. So I need to import the library that do that. This is the library. I hit Shift Enter again, so it installs on my platform. And in here, I hit Shift Enter. For time is the time, how much time I need for my program to run. And in here, it says there is no X string. So the X I have defined in here. I need to split it into training to train the model, and the other data I will not touch it because I'm going to test my model with it. So we go back to copy paste that code. Here we go. But we need to shuffle the data. So it's like the most random use case when the data is shuffled. So when you see 1, 1, 1, 1, 1, you're gonna predict 1. But when you see 1, 1, 0, 0, 1, 0, 0, 1, you make sure that your program does not think the data is ordered. And we hit Shift Enter again. In here, we hit Shift Enter again, and here we go. The CPU in here is much, much faster than the ones that you might have on your own laptop, and we can even accelerate that with GPUs. So, oh my God, it's like 30 minutes already. Now this is my model. I can download it. I can use it on other data to classify the sentiment. So like this is a sentiment analysis use case, classifying. So I'm gonna edit this to sentiment analysis. I know that I have shared with you a Kaggle link, but I did not have used the codes in there. I just make up my own code. And let's make it look a little bit feisty. I like this emoji a lot. Fire. Okay. Sentiment analysis use case. Good. I would be really happy if you watch the whole thing. I know most of you are business oriented, but believe me, you need to know the basics. You need to know what you are getting into. So now the model, I do not know if it performs good or bad. So I need to make predictions on unseen data by the model. If you think I'm talking funny, it's just because I try I'm improvising most of these things, and like I'm trying to be as simple as possible so you can understand these kind of things. So it sounds a little bit funny. So this is the X test, and this is the unseen data by the model. The model never seen this, and we're going to calculate the accuracy score, the precision score, and the recall score to verify if the model behaves in a good way. Oh my God, is 93% accuracy. So most of the time my model will work, hopefully for your startups too. And since the source code is working, then I will use the whole data for that. But before that, I wanna change. Let's have a better looking. Okay. I want to have a more optimized source code and more better looking source code. And for that, I'm gonna use this. It took me a while. It looks so simple, but it took me a while to figure it out. So in here, I will go through. I'm gonna use a different classifier. It's called stochastic gradient descent. And I'm gonna give, so model, I'm gonna call it model one. Model one. In model two, by the way, I did not use a spacey like to be optimized in here. Okay. Model two, we're gonna put our best efforts into it. So here we go. We're gonna use, so these two steps, I'm gonna combine them into one step, and I'm gonna use a beta classifier. I'm gonna put the parameters that I want my algorithm to use when he's learning. And I'm gonna search for the rest of the best parameters. Let's assume you have like a model, an algorithm is called SGD, like the one I'm using. It has like 20 different parameters, and you don't know which parameter behaves the best. So you put all of them and you tell your algorithm to figure out the best parameter by itself. So we call this hyperparameter tuning, and we have the famous grid search cross-validation to do that. And by the way, it cross-validates what it learns. This is super powerful, and it will be condensed into few lines of code, which is phenomenal. I have developed the source code yesterday. Hopefully it works today. And here we go. Okay, he does not know that library. We're gonna import it. It's called TF-EDF vectorizer. So we used a count vectorizer with TF-EDF vectorizer and a transformer. Then we combine them together. And a stochastic gradient descent classifier is a very powerful algorithm, by the way. But it's kind of underrated. I don't know why. And we need to import our hyperparameter tuning and run again and run again. And here we are. And hopefully it works. And here, like I said, we give him too many parameters, and it gives me here the best combination of parameters. So we call this hyperparameter tuning. And by the way, we have talked about this great function. Where it is. This one, but we did not use it. So this is the time when we're gonna take advantage of it. a little patient. Be a little bit patient. So in coding, you do not need to memorize everything. So that's my private session. I cannot share that with you. I'm gonna verify a small code that I have wrote. It's a way for me to use a Spacey to clean my data and I need to verify the version that works because I have done a lot of versions, but for the sake of this tutorial, we're gonna use the one that I'm sure it behaves in a good way. Otherwise, there's no big problem. But I'm gonna show you like how to incorporate different softwares. Some call them softwares, frameworks, libraries. Like it depends on the resources that you are reading. So in here, the way we're gonna tokenize our data is through this one. I did not try it before with TF-EDF vectorizer, but I tried it with I tried it with count vectorizer. So this is like the first time trying this thing. Okay, we're gonna use this Spacey tokenizer. Here we go. Shift Enter. The task has failed to unserialize. Please ensure that the arguments of the function are all pickable. Okay, like I said, this is like first time, and I'm not sure if it works. So we're gonna keep it simple, Shift Enter, but we will try if it works in here. So Spacey, so it's actually tokenizer. Spacey tokenizer, yes. Shift Enter. And it works like a charm. Now I have a recall of 1. So now using this one, I know that my model will perfectly generalize on any review for Amazon Alexa. And I know a lot of you are working on chatbots. So maybe we will sentiment analysis, Amazon Alexa reviews. We will edit this so it's more visible to you. We will try to put an emoji. I'm not even a social media guy, so please do not think I'm big into emojis, but like they are expressive. Which one will best present Alexa? Let's put a rose. Yeah, everybody likes roses. I'm allergic to them though. Save. The use case of tonight is classifying Amazon Alexa reviews into positive reviews and negative reviews. Okay. And the sentiment analysis thing should be sentiment analysis use case for chatbot data. Chatbot. I think sentiment analysis use case for chatbot. For me, I'm using DI because it's like saving all your data and use it against you. Do not tell that one. I'm just kidding. Okay, now we have two different models, and in here we are doing much more complex work than we did in here, but it gave us great results. So now we're gonna run this on the whole data set. But let's see how big is my data set. I'm gonna say data frame, Amazon, dot shape. Yes, and shift enter. 3,150 reviews. Oh, I did not use, so I'm gonna train my model again and see if that changes. It's gonna take more time, of course, because I have more data, but my second model, I did not use prediction to see how accurate it is. So model GS fit, model GS predict. And my accuracy have went down. I used to have 93%, now it's 92%, but like this is like excellent. In real life use cases, if you have more than 60%, that's good. I'm gonna train my second model and see how accurate it is. And it's 91%. But for me personally, I will use the second model. And I did not use the hyperparameters in here. So TF EDF, I need to put use EDF. And stochastic gradient classifier, the alpha needs to be like this. And even for the EDF, I need to put 1, 1. So in this function, I'm trying to put various anagrams. So instead of like you have a text, every word is going to be put by itself. We can like put 2 words together, 3 words together, and we will try the best combination. That's what anagram range is. So I hope you like this first workshop. So I'm gonna show you how to save it. You go here, and where did I put it? Classification. Okay, file, save a copy in GitHub, yes. Now it's gonna open my GitHub in here and save it there automatically. So GitHub is a Microsoft product, Google Colab is a Google product, but they work in harmony. Be like Microsoft and Google. NLP from 0 to hero. And you need to create it using Colab, so then you can click one button and go back to this platform. Include a link to Colab. And now it's gonna open in a new window. Hello, beautiful working source code. Okay, just click one button and you can execute it and do whatever you want. Gonna verify it's in here, and boom. So I'm gonna delete this atrocity. Goodbye. So I have deleted that. The library, the folder is gonna be deleted too because it has only one file and I have deleted that file. So you're gonna see the date, always go to the most recent one. And now we will go and discover another library. It's called Spacey. I know we have used Spacey with scikit-learn, but now we're gonna use 100% scikit-learn, and it's gonna be a black box. We're gonna use Spacey transformer. And before I forget, you can follow me on GitHub. Most of your ideas, you will need some source code from here, which I give for free. You can follow me. You will find some follow button. And this is, you're gonna have, so the Arctic Code Vault is in Antarctica, and it's a project by Microsoft to preserve the whole world source code into a safe place. It's like a seed vault, and like the seed vaults, if you know them. I know one in Norway, it's in the north. The name of the city is Salgerbad or something difficult. And you can find a lot of AI projects in here, a lot of website development. You can just use it for free. I do not charge anything for that, but it's on your responsibility. By the way, too, I have a lot of live streamings with prestigious universities in prestigious summits. You can discover the whole videos. I always share them. It's like a YouTube channel, but for the developer, for a geek. I'm a geek, proud one. That was our little break. Let's go back to real coding. NLP from 0 to hero. We will go to Spacey, and this is the binary classification that I have made for you using a black box. So before, we have used things that we can explain, but in here a lot of things, and this is like a very recent version. It was released last week, and the documentation is not that good, but like it's really robust for big use cases and for production environments. So if you feel that I'm a little bit slow, it's because I'm super tired. Honestly, spending most of my days doing this kind of things, sometimes it's a bit overwhelming, but I can code through this night, so bear with me. And here is going to be a binary classification again, but this is like the second one. So the first one is 0, the second one should be 1. And we will try to copy paste most of these things. Well, first let's verify. AC. We need, so when you do this work in your laptop, is going to take you a lot of time, because you need to install a lot of things, and installations that are not the most convenient. The source code is not organized, so we will organize together. Yes. Libs. I will start by the one that I need to install. And these are the installation instructions in a very complicated environment. But in here, they're gonna look just easy. So here we go. By the way, the versions will be different. So I will install the last version. And the models we are talking about in here, and the models we're gonna download, they are very heavy. And there are a lot of requirements. There are a lot of requirements. Like if you have any problem in one of these lines, it's gonna be like tough to follow on your own laptops. But on cloud, like you see, everything works like a charm. This is my model. It's like more than 700 megabytes. Very, very large model. And by the way, downloading in here is like from Google servers, internal Google servers connection. So like you can download 1 gigabytes in a couple of seconds. Successfully installed. Okay, good. Now the third one. Now yeah, that's when you work on your laptop. The other ones, they will install directly. They will be installed directly. I know you will be a little bit confused. Working on the cloud is really different from working on something else. Something else. Shift enter to import the things I have installed. And maybe we need to restore the kernel. The kernel is like a virtualized environment for you, like to do all these cool things. And by cool, I mean cool. Like this technology are really transformative. And this is the dictionary we're going to use. So the dictionary, we're going to use the small dictionary because like the big dictionary is a little bit heavy. Maybe we're going to use it. Okay, could not find this one. Let's go back and see how to find it then. Okay, you little dirty guy. This source code is much better. Pip install more user spacey, Python more and spacey validate. Yeah, I'm gonna use that. And then I'm gonna download the dictionary and I'm gonna use the big dictionary so you can see how great this. By the way, if you do it from scratch, is a hell. A little big, not a little, it's a big hell. Shift enter. This is the one I said it's more than 700 megabytes. Take your time, baby. And it's been almost 1 hour. After Spacey, I'm gonna go through a little bit TensorFlow. TensorFlow is like it's like a software, like the biggest AI software that you can find on the market, and it's free. Like you see, 700 megabytes, 777. Damn. Downloaded successfully. with my employer in our like tech stack environment. It takes days to do what we did in a couple of seconds. Believe me, you should be grateful for this free, open, amazing environments. I know it's a bit crazy, I'm repeating myself, but one day you will know. And in here, I'm going to use the big one, it's the large one, and shift enter. It works like a charm. Thank you, God. We're going to import our data like we did previously. We're going to upload it. And by the way, we can bring it directly from GitHub. Like bring it directly from here. It's Amazon Alexa reviews. And for you, you can download it from here. Reminder, yeah, I know. So this is like a temporary environment. So every time you put a code in here and it's inactive, like I think 15 minutes, the kernel will stop and you will lose your work. Like you will lose what you have run into this kernel. But when you go out, even the data is going to be deleted. So you can like save it in GitHub and go back and do it again. Okay, these are my libs. Now I'm gonna bring the data. Hello, content. Nope. Are you gonna do this? Nope. We're gonna copy the path of the data. It's the same data we have used with scikit-learn. We're going to use it with Spacey, but like the pre-processing steps are a bit different because we are dealing with a different. We are dealing with a different framework. Print shape. We have printed the shape. And we're going to do this. We're going to convert the data that we have into a list. So we have imported it as a data frame using pandas. Then we're going to make it a list. And then we're going to visualize what we have. No need for timing. Shift enter. What can I say? Well, I'm paranoid IT person of 30 years. Oh, this is a person like me. Hello, buddy. This is one of the reviews and one, it's, let's see if it's positive. Yeah, it's a positive review. This is from the data that we're going to train, and this is the test that we're going to use on the model that have used the trained data. Now we will try to do some processing. So some review, so I need only to do positive reviews and negative reviews. For Spacey, you can do like neutral reviews. And it's actually beneficial to know the neutral reviews. Some people, I like this about Alexa, but I did not like that about Alexa. This kind of neutral review. But for us, it's a binary classification. Otherwise, it's going to be multi-class classification. And we do not want to do that. Simply to keep it simple. So we're going to test if this function works. So everything you do in coding, you need to test it afterwards. We're going to like binarize our data using the document thing. So it gets binarized. The word positive is 0. The word positive is 1, and the word negative is 0. And neutral is 0. And now we will, okay, I'm gonna copy it first. So we have tested if the binarization works, and it does. Now we're gonna binarize the whole document and we're gonna save it. We're gonna save it, it's gonna figure out in here. Like you're gonna see it most probably there. So Shift Enter. It takes some time, but it's very, very fast on Google Colab at least. I'm gonna prepare the next block. So this is for the train data. And boom, the train data is processed. This is, we process them. So later on, they are ready, so we can train them. And this is like the tests. Once it's processed, it will be in here, good. Now what we're gonna do, this step took me a while to figure out because I'm not an expert on using Spacey. And we're gonna call this step modeling. So here we go. Now, what does this line say? We're gonna actually run it and we'll talk about it. So it says the file base config does not exist. So I need to configure how my model works. So I'm gonna go to this website and configure and put together a file that has the configuration of my next model. We want to classify text, so it's a text categorization, and each category needs to be unique. There is no overlapping, so exclusive categories. We're gonna run it on a CPU because we do not need a GPU. GPU actually is not always faster, and we want efficiency. So it calculates a little bit faster. It's better for production environment. Accuracy, if you have like a very like in trading, accuracy is going to be better. But like if you are trading every couple of milliseconds or seconds, efficiency is going to be better. This is the configuration file. It automatically creates after like doing this, and you can use it on other languages. Too many informations I know, but bear with me. I'm going to download it. Oh yeah, I'm going to put it on the desktop, and then I'm going to upload it in here. And boom. Now I will try to run this code again, and it works like a charm. Do not disappoint me code. Actually did disappoint me. Oh, I did not put the path. Just enter. Do not disappoint me code. I do not have the whole night. Good. It works. So now, after configuring the model, what we need to do is just run the model. Shift enter. It's going to create a training folder to be structured. Oh, by the way, I forget a step. So after configuring the model using the configuration file, I created a new file. It's called config configuration file. And it's in here. I need to copy the path of that one too. And I put it in here. Do not disappoint me code. I do not have the whole night for you. Here we go. It's training. When you see like the score is always the same, that means your model sucks. And this model is overfitting. Actually, I think it's underfitting. But the code is working. What you need to do by yourselves, ladies and gentlemen, is to improve the source code by yourselves. I will not do the whole job for you, but I have given you a fully working source code. But in here, the loss is going, is better and better and better. Anyway, now I'm gonna load the model I'm using. So, sorry, I'm gonna show you. Simple. This is the training folder that I have created. This is the best model I have created, and the data about this model is in here. You can find all the details about your model. I will not explain all of that to you, but this is like the performance of it, and you have recall, F1 score, precision, and every metric for every category that you have. And here we go. So I'm gonna copy the path of the best model and I'm gonna use it. Okay. I'm gonna show you the data that I want to apply the model on. So easy setup, works flawlessly. This is like a positive review. Now I'm gonna test if my model works on this or not. So I developed this function to evaluate my work, and let's see if I hate my job. I hate Alexa. Okay, that's not very positive. I will put, let's say, this one. Yeah, some days I just don't like my job. It's difficult and time-consuming, very stressing, whatever you want to say about it. Just enter, name demo. Oh, missing a D. So the model is saying that this review is positive. So the result, so I'm gonna take this one out. And my model is fully working. Ladies and gentlemen, believe me, that's a real chatbot. It's Alexa, those are real reviews, and you have real everything and real results. So what we're gonna do now, we're gonna save this beauty into my working directory. Save a copy in GitHub. Yes. Could not find any public repositories. Oh, wow. Like suddenly you do not want to work. Is my internet connection on? Yes, it's working. What's happening to you? It seems like it's taking forever. Okay, cancel. Yeah, that's weird. But if GitHub is down, that's like that's a nightmare for a lot of people. GitHub is not responding. This is like one of the rare things that happens. Wow. Really, wow, GitHub is not working. Okay. Let's enter GitHub from here. I can't believe it. Like the downtown for GitHub is like default tolerance is 90%, 0.99999%, 9999%, and it happened tonight. Oh, you are working again. Shame on you, Microsoft. It's so slow. By the way, my internet connection is working really good. There is no problem in it, but GitHub seems to be really, really slow. That's unfortunate because like we have done the heavy lifting and what is left, like saving the model. Wow. Like this is rarely happens to GitHub. You see now the frustration, but like you have a lot of platforms like this, a lot of softwares like this, and every day something really happens. Like but on GitHub, like this is like the second or third time I see this in a couple of years. Bill Gates, you need to fix that. Actually, Nadia Satya, or I never remembered that guy's name, this current CEO. Please work. Okay, we're gonna do it the odd way. We're gonna download Python notebook. I'm gonna save it to my desktop, and then I'm gonna upload it when Mr. Microsoft's product works. Thank you. So guys, with me you have like the rest of the work is TensorFlow, and TensorFlow, like I said, is the biggest. It started like a small framework, now is the biggest software for AI development, and all my work is on TensorFlow, so I cannot give you like what I have developed for engineering students. That's unfortunate, but you have learned with me how to use scikit-learn, which is like the most beginner friendly, and it's super efficient. It's not because I said friendly and like simple use case, it means like it's a dummy thing. No, it's actually, it's my favorite machine learning software. And we have learned Spacey. And for me, I have learned Spacey last week. It took me a week to figure out a lot of things, especially with the new version, which is poorly documented. You need to watch out for the versions too. And I made it last week, and I have shared most of what I know about Spacey tonight. For TensorFlow, it's the same repo on GitHub, NLP from 0 to hero. Like this is weird. I'm avoiding eye contact with my webcam. This means like I'm too tired. So you can go and see level 1, level 2, level 3, level 4. Those are my the labs that I took from Coursera, TensorFlow NLP certification, and I tweaked them a little bit and I shared them with you. By the way, they are open source, so I was sharing Murdo, so the engineer is from Google Brain team, and he's working for deep learning.ai, I guess. And he created those notebooks. I'm taking advantage of them, so it will be great for you to discover them. Otherwise, I'm gonna give it the last try. We had issues producing the response to your request. Sorry about that. Yeah, the website is down. So hopefully, guys, you loved learning about scikit-learn, about Spacey, about NLP, using those two. The third one is TensorFlow. It was going to be 10 minutes, 15 minutes stop, because I was not going to execute everything. It's too much for you in one night. Hopefully, if you liked what we have seen tonight, let me know. Otherwise, if you have any questions, please DM me, or like in Town Square, send me your thoughts. Thank you so much and have a great weekend. Goodbye.